Okay, ready? We should get going because we've wasted enough time.
Just half an hour. It's all
Yeah,
right.
just half an hour is ranting and finding a record button. Okay, here we go. Hello and welcome to the Cloud Therapist channel. I'm Richard Simon. This is the September 2024 episode of Cloud State of Play. As always, I have the pleasure of welcoming back the unforgettable Paul Bevan. Paul is the Director of Infrastructure Research at Bloor Research. Yes, let's say hello to him again and welcome him back to another episode. Paul, how are you doing?
Good. How are you? I'm.
Um,
Yeah, go on.
Oh, I was going to say I'm fine now. The panic over. By the way, we've just been trying to find the record button on the Zoom app because I upgraded it from the previous version and the record button was hidden away somewhere. So we just spent the last half an hour trying to find that and eventually found it. But yeah, panic over. Okay. Yeah. So Paul, thank you for doing the September episodes again, and we have another three topics as we always do, right? And hopefully they're going to be of interest and slightly controversial. Maybe we'll see how we get on with the content itself. But the topics for September are cloud computing is simply a consumption model. So Paul wanted to kind of re-emphasize that point because a lot of people, and including the press, seem to have forgotten about that original concept of cloud computing. So the kind of looking at the underlying technologies and what's kind of has made it really possible and so successful as well. So that's the first topic. Second topic is why the backlash against microservices. I seem to have noticed quite a lot of ink being spent on writing about microservices and how bad they are and so on recently. And the press again has picked up on that and maybe run away with it a little bit. So is microservices architecture the only game in town? That's kind of where we're going to sort of go with that one. And we'll see what comes out with that. And then the third one, Paul wanted to touch on data fabric. So what is data fabric? This is, I think, an important aspect of kind of having a wider or bigger picture of sort of data and how you sort of deal with your data in the enterprise. Where does it get stored and stuff like that? And kind of the data fabric is part of that process as well. So we'll certainly be focusing on that a little bit more. And as I said, we don't shy away from controversial topics, so we'll see how we get on. So Paul, if you're ready, we can kick off with the first topic. Are you ready to go?
Yeah, ready to go.
Fantastic.
Yeah.
All right.
Go on.
Yes. Yeah. All right.
We're well synced.
So our first topic is cloud is simply a consumption model. Now, I know you wanted to touch on this a little bit. I had a couple of points to come in, but I'll let you maybe start on that first, and then we'll see how we get on.
Yeah, it's coming about, I think, because cloud has become such a ubiquitous term. I mean, this is not going to be about, is cloud the right way to go or should it be cloud? It is, cloud is, it's successful, does what it's supposed to do. But I just get frustrated. I suppose two things. Firstly is, you quite often get asked by business execs who are just not tech savvy at all, what is this cloud stuff? Where is it? All those.
You still get asked that?
Oh, you still get asked that, Yeah, I mean, there are some who seem to be, revel in the fact that they don't understand. My IT people are saying now to go cloud first or all in cloud. Where is this cloud? And I mean, I'm caricaturing it a bit, but there is a lack of understanding, and part of that is down to the way in which cloud is being used indiscriminately by vendors, particularly who are desperate to be seen as with it and in this sort of cloud native world. We've got a cloud, and actually when you look at it, very few, and that's unfair. quite a lot of particularly when you get into things like SaaS, they've moved their applications to the cloud. They're now, it's really no more than, an old managed service or an old outsourcing contract. I mean, it doesn't have, I always liked the fairly simple National Institute of Standards and Technology, the American NIST organization.
Definition, yeah.
2011 sort of put together the sort of 5 essential characteristics of on-demand self-service, broad network access, resource pooling, rapid elasticity, or say that, put your teeth back in, and measured service. And sometimes you get this sort of sense that people simply, from a marketing perspective, put the tag, oh, a cloud, and when they're really saying, it's in my data center and you can access these applications from my data center, but they've done very little with it. And that sort of brings back in the other question is, actually, it's the technologies that around, I said this would bleed into the second part, around the whole microservices arena, all the new technologies that have made cloud possible, for all the reasons that, that we know it's been successful. And therefore you get this sort of common misunderstanding that comes because you're using the term cloud to cover both the underlying technologies. So people will talk about cloud technologies and vendors who are sort of desperately trying to look cool, saying, you can access my application or you can access this service, on the cloud. And actually it's, if you look at the underlying technologies and the way they've set up, it's not a cloud tool. But that's my main concern is that, that's what's been going on.
Yeah, I mean, I think for me, it's kind of, if we sort of, there's certainly a lot of still ongoing misconceptions. And if you speak to somebody who's outside of the, that space or IT in general, I can appreciate that they don't understand, whereas you're kind of using an iPhone and you've got this thing called iCloud, but you have no idea what iCloud is and what it's doing. Basically, you just have access to your documents, photos, or whatever you're storing there, but you have no concept of how it works. So I actually, funnily enough, described this recently to somebody at the pub over a nice pint of beer, as you do, who is a complete layman. He just uses stuff, but I needed to collaborate with him on something, and I explained the concept of Google Docs, for example, or sort of using Word online, with Microsoft Word and things like that. So I kind of stepped back from that, a couple of points, and then talked about sort of, okay, so how is that working? How does that work? And obviously that's, being stored in the cloud somewhere. And yeah, he liked the idea. I mean, we thought that was, okay, that's cool. Yeah, we can collaborate. And it's the same document, it's live. What changes you make to it, I can see, and we can do that live. We can do it on a Zoom call, together and so on. So I kind of explained how that, very layman terms, sort of how that sort of cloud concept works. But really, anybody else who's even remotely within the orbit of IT and tech in general ought to have at least a very vague idea of how cloud is working. But yeah, there is still misconceptions, and the biggest, I think, misconception still is around the shared responsibility model. I still see a lot of misconceptions around that. And, early on, we had things like, I didn't know how to do my own backup and recovery. So that was one thing. And then the other one was, but the cloud, the cloud service provider is taking care of security, aren't they? That was another misconception. So I think those were kind of the early ones. And now it's kind of, rotated around to things like cost, the actual, the design or the architecture that we have, the operating model that we have in the cloud. Have we chosen the right operating model? Are we doing the right things? Our processes, are they correct, and so on? And that's obviously led to so-called sort of cloud repatriation myths as well.
Don't start you off on that one.
No, I won't start on that one. That's not our topic for today.
Yeah, but again, this just highlights the way in which the term cloud, by using it for, let's call it the location, where is the cloud, and how do you put a cloud application and cloud systems together to make cloud really work the way it should do? Requires all these different, different technologies beneath it, and I think people are blissfully unaware of that. So when their legacy supplier, sorry, I mean, or their on-premises application, somebody says, "Oh, wrap it in a container and put it in the cloud," it was never going to run properly, and people didn't understand ideas about agility and scaling and all those that
Yeah.
the cloud's all about, and they wonder why it's costing them so much. I mean, we can argue the toss around, the cost side of has it become too complex and too complicated for people? But the reality is that if you want to really scale applications and you really got a global footprint, are you going to run it in your own data center with, old style applications? The answer is no. And the other thing I try and get across to people, a bit like your sort of conversation around Google Docs, is, stop thinking about the cloud as some sort of amorphous, woolly thing, everywhere. All the data, all the applications, all the networks have to land on a piece of hardware somewhere. The big difference is you're no longer responsible for that hardware. Stop worrying about it. It's not that we've sort of changed the paradigm, and we haven't quite got to quantum computing phase yet. I'm sure in 10 years' time we'll be having this conversation around quantum, but you get the same sort of sense that people have forgotten about it still needs to reside on silicon somewhere.
Yeah.
And where is that and who owns it? And then you come back to, and one of the things, again, I stress to people when we're talking about this is, can you think of any rental model where if you keep using it over and over and over again, will it be cheaper than buying it outright? And the answer is usually no. If you rent, and there's various reasons for renting stuff, whether it's you haven't got the capital to use and it's a handy way of doing it, or very variable throughputs, all those sort of issues. And so people just stop thinking along those lines when they hear the word cloud. And so that's what I wanted to say to them. It's a consumption model. Now go talk to your IT staff about the underlying technologies you need to put it together properly. And actually, you could run it in your own data center if you really wanted to. The cloud would now be in your data center, residing on your silicon. It's a consumption model, and you sort of see the penny drop with people after a while that says, okay. And what I want them to do is to ask, vendors with applications that are now, having been on premises for many years, suddenly they've got a cloud version. Have you actually re-engineered it for the cloud? Or is this just a managed service or an outsource? And that's really, so I just wish people would get, say it's a consumption model and there's some underpinning technology that has made the cloud as successful as it is. That's really what it is. Without all the new technologies that have come along in the last 10 years, cloud would not be a successful model.
Yeah. Yeah. And I mean, yeah, you touched on kind of sovereignty and security of your sort of cloud and certainly your data if it's in the cloud. So that obviously makes sense. I think for me, though, things like, the private cloud model is, I think now, many years later, is in complete shambles. As you said, everybody, for me, as far as I'm concerned, everybody's calling whatever they have cloud. Even hyperconverged infrastructure is now a cloud. Yet, a few years ago, the likes of Nutanix and some of the other players have all gone defunct now, or got acquired and merged into a larger IT vendor. All used to be happy with just calling it, software-defined storage or hyper-converged infrastructure.
Yeah.
But because the cloud is kind of, running a runaway success, they've, all their marketing stuff has had the find and replace treatment, basically. It's, you know, it had the
I raised my case
to it.
You know?
Yeah. So yeah. So I mean, and unfortunately, I think out of that, things like private cloud has been muddled. You've had, you know, input from the, as you said, the sort of, so the incumbents, the existing vendors, you know, in the data center space. You know, others are kind of coming in with, you know, some tooling and then saying, oh, this is a cloud as well. You've had the hyperconverged players, and even the public cloud providers have kind of, you know, thrown some money behind that as well with their own, you know, platforms as well. So the, you know, AWS Outposts and all the other ones from, you know, Google and Microsoft. Microsoft, I'm not sure, it's kind of, you know, it's Azure Stack, I think, Azure Stack and Azure Stack HCI, and you've got Anthos from Google. They announced something different just quite recently as well. I don't know where that kind of really fits in yet, so trying to get my head around that. But yeah. I think that just that space is really confused. And unfortunately, I think what I would get out of that confusion is that there's no easy way to actually do a private cloud anymore. Previously, you had this kind of, you know, private cloud idea. Maybe you had a hybrid cloud idea. Not I think many people adopted a hybrid cloud idea. But now that private cloud space, I think, is extremely confused because you have all these, you know, sort of pretenders who are kind of, you know, pretending that they have or they're offering a private cloud. But really, that concept of cloud being a consumption, if you want to do that, you're going to have to build it yourself in most cases, unless you adopt things like Outposts or Anthos or Azure Stack or, you know, something like that.
Yeah, but even those, you know, the whole concept of private cloud, almost, unless you run it in, you know, in AWS or in Azure or wherever, you know, it almost doesn't fit the NIST specifications for being a cloud. Doesn't stop you saying, actually, if I'm going to write new applications, I'll use all the latest technology. I just don't trust the public cloud for whatever reasons. Maybe it's, you know, there's governance issues, there's sovereignty issues, all those sort of things. That's fine, there's security. Yeah. But don't let that stop you using the modern technology to give you a cloud-like environment. Yes. But it's not cloud.
It's not cloud, but you can achieve. You're quite right in terms of the app at the, you know, the app layer of the stack. You can achieve, and maybe some of the infrastructure below that, you can achieve it. So you could run, I mean, if you really wanted to, I wouldn't recommend it, but if you really wanted, you could run things like, you know, Red Hat's OpenShift on top of VMware. So your VMware is kind of your, you know, your sort of data center stuff, and then you can put something like that on top, and then all your services, 12-factor apps, and, you know, cloud native whatever designs and microservices and everything else is kind of running in that OpenShift sort of layer, if you like. And so you've essentially got Kubernetes and containers.
I mean, you can put it back down to bare metal. I mean, there's no reason you should.
Or you could do that exactly.
Underneath it.
Yeah.
For, you know, for the sake of efficiency, stop layering stack after stack after
absolutely stack. And this is why I don't see the point of, you know, things like OpenStack and vSphere anymore, and, you know, hypervisors in general and so on, because, you know, we've proven and we've shown that you can actually run things like, you know, containers and orchestration directly on bare metal if that's what you really, really want to do in your own you know, systems and in your own data center, if that's what you really want to do. And that's fine. I mean, if that's like, as you said, if you're kind of, you know, restricted by regulations or your market sector or government or whatever, that's cool. That's no problem. But that shouldn't stop you from, as you said, developing those, you know, more modern applications.
Yeah, I almost think you know, it would be lovely, and it's not going to happen, but it'd be lovely to get the vendors to say, if it's a proper shared service, you know, genuine public cloud, great. Otherwise, I'm not going to call it cloud. You know, call it a managed service or whatever. I mean, and you get, as you say, even AWS and Azure and GCP have sort of fallen for it too, with edge cloud. You know, and you think, oh, how can you have an edge cloud that meets all those criteria? I mean, I challenged one vendor that was not. It was a small vendor that was focused on really out on the cloud, you know, out on the edge. And he was talking about the fact that he got a sort of, it was an edge cloud. And I came down to the thing that said, and he got a relationship with Dell, and that they were sort of provisioning everything for him. And I said, yeah, but if you're out of the manufacturing plant and you need suddenly to do it, how do you provision that? Oh, well, we've got rapid access and vans that are there, but that's not instant. That's not cloud. That's not automatic scaling, up and down. That's the key thing. It's almost like if you can't, it's not.
That's like just normal hyper-converged infrastructure or edge computing.
Yeah,
basically, but it's not an edge cloud.
Yeah, and so I don't believe in edge cloud, full stop.
Well, I think it's, for me, I just see what the public cloud providers have done, with like I said, Anthos work, what's it called? The AWS one. I've forgotten the name now. Outposts. And Azure Stack. You can put those in your data center. You can take them to the edge if that's what you really want to do.
You can take them to the edge. Then it says, "Oh my goodness me, we've got this surge in throughput. How do I now get more compute power at the edge?"
Yeah.
AWS can't suddenly manage to get out of thin air. So it's crazy. It's nuts.
Yeah.
Stop calling it.
Yeah. It's
and then they talk about edge data centers. Well, of course, it's at the edge data center. It's still, when you talk about it, it's probably still 60 miles from the actual real edge of the company that company's system you're talking about.
Yeah.
Oh, for goodness sake. So I do get frustrated by that.
Yeah. I think it's kind of more of a design or logical sort of reference than, as you said, kind of, if that thing is literally running on the edge, and there's nobody there, there's no IT support there, and if it's running out of, so that literally that system's running out of resources, or needs to burst, for some reason, I think the only way to allow it to burst is to burst back into your public cloud environment.
Yeah,
but then you'd have to put in the effort to make that happen, and so I don't know. It is a bit convoluted.
Yeah, and just coming back to the consumption model piece, is you say, look, this is about, can you guarantee that you can scale up and down and pay for what you use? Or are there all sorts of barriers to doing that says there are fixed costs in there that you can't get round?
Yeah.
That's not cloud. And so just stop worrying about it, but don't then throw the baby out with the bathwater, and end up not using the really great technologies that have made cloud possible, which you can run in your own data center.
Yeah. As long as you have that abstraction layer, you decide on an abstraction layer, whatever that abstraction layer is. It's Kubernetes, it's OpenShift, or whatever. As long as you decide on that abstraction layer, then that allows you to develop whatever you like at the sort of above that abstraction layer, and not really worry about too much about what the hypervisor is necessary, if necessary, or is it running a bare metal? Is it running in OpenShift or whatever? And you shouldn't really care too much about that. And that actually allows you that. And obviously, one of the ideas of cloud computing is to do that abstraction, right? That's the whole idea.
Oh, absolutely.
And cloud native obviously being the other, but certainly abstracting from the hardware, so you're free from anything physical when it comes to provisioning a service, a business service. So everything's digital, everything's in software driven. That's really the main idea. So as long as you kind of keep that in mind and work towards that, what is my abstraction layer? How can I got a fleet of VMware, I've got a fleet of Nutanix, I've got a fleet of servers, hardware servers. How can I abstract what I'm going to do, what apps I'm going to put on top from that platform, from that underlying platform? So that abstraction is really important.
This may well feature in our next conversation.
Oh, it may do.
I'm absolutely sure that the two would start to bleed together, because there'll be interesting to come out of the next one. But
but I mean, your architecture and design has to be adaptive. That's really the idea for me. And cloud computing, because all cloud computing is always going to move on. It's always moving on to the next thing. We're kind of, microservices, and the next thing is WebAssembly or whatever, down the line. So the latest tools and open source, and cloud native is kind of always going to be moving things forward. It's always going to be another project further out west that you need to go to. So you have to be kind of adaptive in that way.
Yeah, the whole of the industry works in that way anyway. So I mean, it's and if you'll get set in your ways, you're going to find it really difficult to move forward.
Yeah, I think it's for me, it's like might be coining a term here. It's like a variable speed parallax view for me. So some of the things that you're seeing in front of you are moving very fast. So that is like, cloud native, microservices, but the stuff that's in the distance is still moving, but it's moving slower. And that might be mainframes and, normal servers, data centers and stuff like that. It's all moving, but it just depends on where you're looking. If you're looking at the front, it's moving very fast, just like being on a train, really. And it's like that kind of, parallax view, right? So you can see things, the trees and towns and houses are moving very quickly in front of you, but the ones in the mountains and whatever, the buildings in the distance are moving slower.
Yeah,
and that's kind of how I define really sort of IT. It's like a parallax view.
Okay. I've learned something new today.
There you go.
Parallax view.
Do you not know that parallax view?
We're using this.
You don't know about parallax view? Unbelievable. I'll have to send you a link on that. It's quite cool. My bottom line really is that, whatever you're doing in that space, it needs to be adaptive. I think, private cloud for me is extremely muddled. When people say we have a private cloud, I go, oh yeah, what's it running on? And that's the first thing I want to know. What's your definition of private cloud? Because it may not be my definition of private cloud. So if you guys have been involved in any of this, let us know. Drop us some comments. Do you agree with Paul? Do you disagree with Paul? Do you maybe disagree with me? Who knows? But if you guys are doing some of this, we'd love to hear from you. So do let us know in the comments of the video. Maybe you guys are kind of running private cloud. What's your definition of private cloud and so on? It'd be really interesting to hear about that. Hey, if you are enjoying the content, please don't forget to subscribe to the channel. That would really help me out. Thank you. Okay, so next topic is why the backlash against microservices. Now, I've been hearing lots of arguments against microservices recently. So I've been asking what the F is going on around microservices. I know that there are some sort of apparent or alleged sort of negatives around microservices. So the service mesh can be too noisy. The setup is too complex or can be complex. How do you manage all of that? Obviously, secure it and so on. And some people maybe have even kind of gone and done microservices for the sake of doing microservices, and almost like a default expectation because we're now cloud native or we're doing more cloud-based services and things like that. So I can appreciate that maybe, being a sort of a little bit of a backlash, or being maybe some of the reasons for the so-called backlash. But it's always horses for courses. It just depends on what you want to do, what you want to achieve. We never said that microservices was for everything, and we certainly didn't say that. I don't think anybody said that once you're doing cloud native stuff and you're doing DevOps and CI/CD and what have you, that whole sort of agile approach and so on, that you now got to do microservices. I don't think that's ever been the case, and there has been also some maybe kind of alternative approaches to how you do it. They still might incorporate microservices in the architecture, but not necessarily, be sort of a pure approach to how you do, microservices architecture. So the likes of cell-based architecture, that was something I actually heard recently from my colleagues at T-Systems. We were kind of talking a little bit about that. That seems to kind of be, coming up quite a lot in conversations. And then the other one was composable architecture as well. So there's subtle differences from these. And composable is kind of a little bit more of a sort of a mantra, a way of kind of doing things where you're kind of focusing more on building blocks, reusable building blocks. Cell-based architecture is kind of saying, if you have a service, then put it all in this so-called cell, keep everything that it needs in that cell, and then separate the cells from each other. Within that cell, you've got things like load balancers, you've got the potentially containers that are running microservices and so on. But they're not necessarily in this kind of service mesh where everything is meshed together. And you've got, microservices on this side that are doing one particular thing, and the microservices on this other side that are doing different things, but yet they all communicate on the same mesh where they don't necessarily need to or shouldn't necessarily be in the same service mesh, so to speak. And that's where kind of obviously microservices comes in. But what's your think, Paul? Have you kind of picked up on this at all?
No, I haven't sort of picked up on in the same way you have. I've certainly never heard of the cells and what was the other I've heard
composable. Yeah,
I mean composable. I mean, it's really just another version of software-defined everything, isn't it? I mean, it's so you can compose it, but the straight answer is no, I haven't really. I mean, I've done some looking at when should you use microservices and when should you use a more monolithic structure. And there are times when monolithic is probably better, and it's usually around latency and performance, because in microservices you're putting various network links in place, albeit very fast. You're creating a potential for more latency, and if you've got a very complex system that requires very, very fast response times, a monolithic architecture might handle it better than a microservices one. Those are, and when you were describing the cell one, the immediate thing that came to my mind was, well, if you make that cell big enough, it's just another monolithic architecture, and you're going to get the same problems of now you're going to have to scale everything, not just the particular component.
Yeah.
You've got a number of challenges that the bigger you make that sort of monolith piece, whether it's a cell or on a composable or whatever side you do, you run into the challenge that says it's going to be less agile than if you use microservices. You're going to have to rescale. When you have to scale it, you probably have to throw a lot more iron at it, because you're having to scale the whole of that piece, not just the service, the individual service. So, it is horses for courses. I mean, you said this right, Dan. I mean, one of the things I was at the back of my mind today thinking was, am I going to have to come out strongly and say, I loathe fundamentalism in all its forms, and it must be microservices, it must be, but no, you're a sensible human being, and you've said there's horses for courses, so I don't need to get on my high horse. But I mean, you do get this sort of fundamentalism. I mean, in many years ago, it was always, we used to call it the Holy War, particularly when Unix was just coming along and having their first battle, if you like, against this new upstart. And it was a holy war. People had religious fervor about it. It was like dealing with fundamentalists. And you go, okay. And I always see elements of it in the sort of cloud native debate. You do get that element coming in. But no, it's horses for courses.
Yeah. And it's the purists, I think you're kind of referring to. An interesting... So I had a conversation with Copilot, Microsoft Copilot, as I always do. And one of the things that came out of it, it said modular monoliths. So that was the other kind of approach in terms of what you will get, from these architecture approaches. So the microservices architecture, obviously not applying to that, but the cell-based architecture, again, not necessarily applying to that. But the composable, I think maybe it applies to that, because you are essentially taking your old monolithic app and breaking it down into smaller components. And that was the conversation I was having. And I said, okay, so we don't have to do microservices, right? I mean, we don't have to go straight to microservices. No, you don't have to do that. You can kind of, just make it modular, right? And then sort of, the next conversation led to the modular monolith sort of concept. So yeah, I agree that. But I think what I'm just seeing a lot of is recently is that, again, the press has picked up on this and they're just running with the fact that, okay, microservices are crap. And I mean, to the point where David Linthicum, who's a quite well known guy around these sort of circles, I think put out a video. His video title was actually "The Death of Microservices?" ? So I mean, I think that's a little bit maybe too far in terms of kind of the saying that. I mean, you could say, are microservices dead, and then you'd obviously have a binary sort of response maybe to that. Definitely not. And then you could kind of explain why, maybe kind of pull it back and talk a little bit about why people are maybe not wanting to go down that path as easily as they were doing previously. But again, a lot of this I'm seeing is because people are now starting to look at their costs in the cloud, and they're realizing their architecture is not actually as optimized as it should be. And then maybe microservices or something else within their environment is an easy target for them to blame for these things. So I think there's a little element of that coming in.
Mean, that comes back to inefficiency in architectural design and in the general system design application design.
Yeah.
So it's unfair to nail that on the mast. I mean, the one area where I certainly feel for this particular group of people, but it's sort of like, we're going to have to suck it up, guys, are the IT operations people, because it's definitely made IT operations more complex.
Yeah.
And when you said about the backlash, I just wondered whether there was a sort of underground IT operations army out there going, I'm going to change this because my life is hell.
Well, I mean, I think cloud ops in general has been struggling, but we do have dedicated sort of approaches to that, like SRE, and SRE should be very hot on running those types of environments. That's their bread and butter.
Yeah.
Just like platform engineering and
we're seeing more
automation
as well. I mean, I expect to see more and more automation in that. Simply, it's getting too much for individuals to manage, so I think but if you've got large complex systems with huge amounts of variation in throughput, you've got lots of different partners in there. Trying to build a monolithic architecture these days is crazy. But there are times when and I'd love to sort of get. They're fairly protective of their systems, but the financial trading, doing high frequency trading.
Yeah,
I bet those are monolithic because they can't. The low latency they require probably means you can't use microservices. I mean, the growth in compute power and the increase in network speeds around have tended to blur the fact that actually there's an awful lot going on in the background that in a monolith you wouldn't get, that you're getting in microservices. But for most applications, processing power, network speeds are such that it's not an issue. But there will be where it is an issue.
Yeah. So I mean, certainly, yes. So certainly other options available. Don't have to go down necessarily the microservices route or bash the microservices route as being, all of a sudden not a viable option. And I think there's, like I said, excuses that people are making, or maybe just pointing the finger because it's an easy target. As a cell-based, as we said, composable. Another one, modular monolith is, after the conversation I had with Copilot. But yeah, so I mean, I think the video that David Linthicum had, it just kind of sounded a little bit, I don't know, I found aspects of it a little bit confusing because the pros and cons, it was kind of ebbing and flowing when it came to sort of the pros and cons. And then I don't know, maybe David was kind of trying to find a balance between those views. I don't know if it was kind of came across. I'm not really sure he kind of managed to pull that off. But again, I don't know. I think I would rather kind of just look at it and say, okay, so what are your reasons for not wanting to do microservices? All of a sudden, why are you hating on microservices all of a sudden?
I think you should bring it back and just think about, what's the business need? What's the outcome that you're looking for in terms of a business application, and how do I architect that?
Yeah.
And the danger is you sort of disappear up your own backsides going, what's the best technology to use, and forget what the hell the business was trying to do. And I think, there is a danger of that, but
yeah, and he has followed it up with another video. I'll try and drop links into the description of this video for all of this stuff, by the way. I think there was a conversation with one of the guys from DoorDash. So DoorDash is the US equivalent of Deliveroo if you're sort of in the UK or Europe. So DoorDash is kind of the food delivery guys. And again, there was a technical debt discussion or topic around in that video from that David Linthicum posted. So again, there'll be links on that, so you guys can have a look at that. I just would have, I think from him, I'd have kind of wanted a more balanced views, kind of good points, bad points, and then I can kind of make up my mind. But anyway, so just moving beyond that, I did kind of do a little bit more digging because I wanted to kind of, okay, so microservice is one thing, okay, but there's these other things, right? So we've got like, cell architecture, we've got composable sort of, approaches and so on. So I said, okay, so what's what would be the differences between these sort of things? So, microservices came out with things like granularity, it's sort of communication via APIs, so API gateways and things like that. It's scalability, as you said, Paul, very quickly react to, a growing business, a growing service that we need within our business. And then cell-based kind of came around sort of things like grouping and isolation and focused communication as well within the cell-based architecture. And then composable architecture was, I think, just like the mantra of what it is trying to achieve: reusability, flexibility, and integration. So focuses on things like seamless integration of the various components. I think, to be honest with you, all of these overlap quite a lot. There's a huge amount of overlap, and if somebody kind of try to, maybe I should do it, trying to put a Venn diagram together, that middle bit is going to be probably bigger than the bits around the circles. So
yeah, certainly the way you were describing those, I absolutely agree with that. I think that it is people trying to carve their own space, and do something slightly differently. And some of those are really valid, but as you say, a huge amount of overlap. Microservices, it's an 80-20 at the moment, as far as I know. It's not quite a default to microservices, but not far off it these days. Why would you actually build monolithic architectures unless you really had to? And I think that's the issue. And I think so. And there will always be a need for some of that, but it's an 80-20. So the idea that microservices, depth of microservices, it looks pretty robust and lively to me.
Yeah, and I mean, and there's plenty of people who I think are running it very well and running it efficiently. I think it's unfortunate that we, like I said, I'd like to see a more balanced sort of thing. It's okay to have a gripe about that, or I say, oh, hey, look, there's a lot of people are concerned about it, for whatever reasons, and obviously one of those reasons is is cost management these days, or cloud economics, and that's fine, but I'd still like to see a balanced view. I don't want to run away with, and I always tend to be against the grain anyway. When somebody says, "Oh, let's go in this direction," I go, "Well, hang on, why are we going in that direction? What's the reasons and what's the compelling event and blah blah blah." So I'd like to see a lot more. And the too noisy. Well, I guess it's always been too noisy. If that's kind of one of the criticisms of it. Not best for all scenarios. We already know that. We never said it was going to be for every single scenario of a service, that a business service that you want to implement or deploy in the cloud. And complexity and cost. And again, what is your architecture like? How did you design the whole thing, and are you was it designed in an optimized way? And like I said, again, that's being kind of shown, or maybe it's becoming more prominent now because of the overall sort of cloud economics that people are are looking at.
One of the challenges of both cloud and microservices is because you can do it so quickly, people just jump straight in. Oh, I can change it. And actually, I think we need to come back to a better understanding of and a better control of the architectural view and the way in which that message meshes with the way the business wants to work. So
yeah, I agree. So another article that I picked up on was from the News Stack. This was actually a little bit older, but it was kind of projecting into 2024, and it said, year in review for 2023. And they said, was 2023 a turning point for microservices? They actually delved even deep, and I think this is the more comprehensive article that I picked up on. So again, I'll drop a link in the description of the video for that. And that seemed to really go into a lot more detail about kind of why people are seeing it. I still, and I appreciated the detail because I really wanted to kind of jump into the detailed minutiae for the whole thing. But it, at the end of it, the conclusion was still the same. As we said before, if it's too costly, do something else. If it's not the right architecture, don't use it. But it certainly has its own advantages, in certain applications. So
the other thing I always say, and as a historian, you have to do multiple sources. I loved it when you were talking about the modular, was it modular monolith?
Yes.
And it was via Copilot.
Yeah.
Yeah. Did Microsoft have an angle there somewhere?
Maybe.
Because I was talking to ChatGPT, researching the same topics.
Yeah.
There was no mention of modular
monolith. Maybe it was. It's all about the prompts.
Right.
It's all about the prompts.
It's all about the prompts. Yeah. Or what's the angle that the writer has got?
Yeah, I think David Linthingham's kind of, I don't know. Maybe his approach is his prompts are different from mine, but for us, Paul, it's all about the prompts.
Yeah. Cool.
So anyway, so that article, I think, like I said, goes into a lot more detail about it, and I found that quite interesting. And then there were some other ones that I picked up on. So again, I'll drop all these into the link. But it was just interesting. I'll just touch on that. It just said kind of discusses the growing criticism of microservice, highlighting issues like increased complexity, communication overhead. Again, that's kind of part and parcel of that design. I have heard a lot about Amazon and Google reevaluating and refactoring how they provide microservices. So their approach, and there might be a conversation on the channel about that in the future. If I pull a certain connection into the right things and get all the planets aligned, then there might be a conversation around that. Apparently, Google put out a Google paper. Google Engineering or Google engineers presented a sort of a workshop that suggested the current approach to microservices might be flawed. So I don't know. I mean, I think it's the approach is sound, but it just kind of depends on what you're going to do and whether it's appropriate for what you're trying to achieve.
They're tuning and tweaking the model, not throwing the baby out with the bathwater. To use tried tested phrase. It is a phase. Cloud is quite mature, and microservices are fairly mature. It is now about tweaking and tuning it to make sure it works properly for as many people as possible.
Yeah, and the internal conversation I had, I won't say too much about that, but the one I had with colleagues, which sort of was based around cell-based architecture, and we were comparing cell-based architecture with microservice architecture. I think that kind of really reflected, to be honest with you, the external view that we've been looking at. I think the only addition, and they mentioned DoorDash. So in the conversation I had, they mentioned DoorDash as part of that conversation. They also talked about Roblox and Slack also as being other examples. But then I think the only other one was kind of more around cell-based architecture being more resilient. I don't know. It just depends on, I guess, what you're trying to do, because a service mesh can be resilient as well.
It's still going to be a trade-off. Yeah. Yes, more points of failure in a microservices architecture. But then again, if some of the elements fail, it tends not to bring the whole system down.
Yeah.
The more monolithic you make it, failure brings the whole lot down.
And they did agree. I mean, I pushed back on a lot of that stuff, and they did agree, that cell-based architecture is not a universal solution, but it's a strategic choice. Anyway, so I think that's kind of where we are with that. Let's see if we can maybe revisit that. I don't know about you guys. I don't know if anybody else is kind of experiencing this or seeing this. So again, drop us some comments. Tell us about kind of your approach to this and how things are. For you, and what do you feel? Do you have microservices implemented? Are you seeing some of these issues around them? That would be, again, really quite cool to get some of your comments on that. It'll be useful to maybe keep the conversation going, keep the discussion going. That will be an interesting thing to see how people are feeling about it. Hey, if you are enjoying the content, please don't forget to subscribe to the channel. That would really help me out. Thank you. Okay, so Paul, let's move on to the third one, which is, what is a data fabric? I will leave this all to you. I'm going to go off and make a cup of tea and come back, and hopefully 10, 15 minutes, your rant will be done.
Until about 6 or 9 months ago, I'd have been in the same boat, and it would have been, I have no idea what's going on.
I'm still in that boat.
I suppose where I'm coming from is 2 points in wanting to talk about data fabric. It's probably worth just bringing those up. Firstly is that from an infrastructure, I'm an infrastructure analyst. Actually, what I've been seeing in the last couple of years, I suppose, growing, and it's very prevalent now, is the impact that data is having on the way in which we architect our infrastructure. And all the pressures being put on that, and AI is just making that. Making that a larger and larger and larger issue. So I was sort of backing into understanding why and what data was why it was having this impact and what was going on. And one of the things that you see pretty clearly, which sort of crept up on me, I think, everybody traditionally would have used almost like a single data type, like relational. And relational was the king on the hill. Everybody went, if you didn't have a relational database, you were dead, effectively. It all had to be relational. But so much has changed. Microservices, cloud, AI, everything is driving a complete new set of databases, whether it's time series for monitoring, whether it's vectors for AI, whether it's graph for things like digital twins, And so you're getting, and you've got object stores, you're getting this proliferation of databases and data stores, and therefore silos of data. And, data warehouse and data lakes have been the sort of way in which enterprises have tried to pull all that together so that they can do analytics on the whole rather than on all in. But we've just talked about speed of change, and your parallel X view. I mean, goodness me, and it's happening very fast here too at the front end. Lots of things changing.
Yeah.
And therefore, how do you get to a point where even things like streaming analytics or real-time analytics? How on earth can I expect a data warehouse or a data lake or a data lakehouse to keep up with this? And so the issue was, how do I get to a point where I don't move all the data again into another structure like a data warehouse and create another silo? And that's the driver behind it. So Fabric, and again, we come back to abstraction. The key in a data fabric, which is really an architecture, it's not so much a product, is that you have to have abstraction of the data layer from the control plane of the storage that's sitting underneath it. So that the data doesn't care, what's going on underneath, and that's effectively what's happened. And you've seen vendors who have got data fabric solutions move towards that level of abstraction where you can take, SQL data, you can take object data, you can take document store data, and it's all, I say, not virtual. You've actually abstracted it, so it now sits in a sort of semantic layer with the metadata, so that you've actually got the ability to leave the data in its own data store and just pull it into this, and the fabric recognizes what's going on and transfers it to the system it needs to without having to do any sort of work in between.
Hmm.
It's got limited, I think, appeal in sort of data transactions, but from an analytics point of view, it makes one heck of a difference. So that layer of abstraction, that semantic layer that is an abstraction layer between the physical, instance of the database and the data on top of it. So the trick then for the vendors has been, how do I make it easy to encapsulate SQL data coming in such a way, or how easy can I make it? And so this is where you're now getting quite a sort of almost like a sort of graphical view, might be like a graph type view of relationships of data. So end users can just start picking data, not having to worry what its format is. Is it SQL? Is it object oriented?
Yeah.
Is it, documents simply, is it whatever form it is? And request the theory, request the information, and the fabric effectively acts as that sort of translation layer, if you like, and you can do it on the fly. It's very fast, and it's a centralized approach. There's a sort of, we call it the cousin. There's a cousin called data mesh,
Yes.
which is a very similar approach, but that is much more distributed, and you're talking about individual domains
Yeah.
rather than a sort of centralized approach. So the example one of my data colleagues gives, he used to work for Shell, and he was giving the example that he named, I think, about 4 different companies that didn't have the word Shell in the name. He says, and then if you wanted then to get an idea about, let's say, total revenue in this particular product set across the data warehouse, had to be constructed in such a way that it recognized that to get Shell's position, it had to recognize the names of the 4 other companies. And then if you put a 5th one in, you're into, oh God, I've got to restructure the query and the underlying schema and everything. So it was a case of, how the hell do we actually, in real time or near real time, and able to do it without moving. And it's enabled you to do it without moving the data. You keep the data in the data store, and just use the metadata and use the way in which the semantic layer works to say, right, just throw the data at me now, and I'll get it ready for the analytics engine underneath. And it does. So you can do it for transactions, but obviously, again, you think, that's going to add a little bit of latency in there. So again,
Yeah.
that's fine. So that's the basis of it. And it's quite an immature market at this stage. I mean, there are a number of vendors out there who are pushing data
Yeah, I was
fabric.
going to ask about sort of the apps and vendors, what's happening there.
So you've got quite a lot of them. You've got a mix of the older one. I mean, Teradata are pushing sort of data fabrics into systems that I've been doing quite a lot of work with, pushing I think a very performant data fabric. It's very
Yeah.
good. Informatica, Denodo, Atacama, people like that are all pushing it.
So most of these people were. So you and I were at Big Data London recently, which is an annual
Yeah.
event. By the way, I did lots of coverage on that, guys. So I will be adding in some reviews and stuff. It's all coming to the channel as well around Big Data London. So you and I attended that. Did you? Were most of these guys there? I think I picked up a
No,
few of the names.
okay,
But
one or two,
but not many of them, right?
not well.
Yeah.
It was strange. There was an awful lot of big data. The big
So
data.
the term that I picked up on, and I don't want to sort of go down the rabbit hole too much, but the main term that I picked up on mostly was data observability
Oh
at that event, but not data fabric. Not too many on data fabric.
no, it's not a mature market yet, and there are some big challenges with it. And the first one is you need a really good data catalog for the whole business.
Mm.
And actually, when you look at it, this is where, yeah, and you've got one or two data catalog companies who are sort of trying to sidle in the other direction. But at the moment, a customer's going to have to stitch together data catalogs, some other governance tools with data fabric. I mean, they're getting there, but at the moment, it's not you can't just go to one of those suppliers and say, I want a data fabric and then expect it to run. You're going to have to get particularly the data catalog up front. And it becomes more and more important. I mean, how many firms don't have a data catalog?
Mm.
Think about that. Data fabric won't work effectively without a decent catalog. I mean, you can do small projects,
Mm.
but you end up with, if you try and scale that to the whole organization and you haven't got a proper data catalog, you'll have a mess.
Yeah, and I did pick up on Gartner actually had a chart on data fabrics, so kind of trying to sort of explain the what a data fabric is. So again, I'll include links in the
We
description of the video for that. I mean,
people know a lot more about it than me. Have written a market update on data
yeah,
fabric, Bloor,
it's kind
so
of
I'll share that.
Yeah, it kind of yeah, I think it kind of touched on the main things that you said about sort of relational databases, traditional analytics engines, data lakes, and what have you, and data stores, even all of that kind of being under the fabric, and then the fabric's kind of on top of that.
Yeah, one of the things that I would I got slightly confused about, going back 6, 9 months was I had this sort of I've got a very visual brain at times. I had this idea that you had this enormous fabric that stretches across the whole organization, all physical in its presence, and right out to partners and everywhere else. I mean, you think about a trading system that brings its sentiment analysis. Is the fabric covering that too? And actually, it's actually quite a tight knit thing around the analytic engine or the transaction engine that sits underneath it.
Yeah.
So, and people talk about centralized, and you think, oh, is this big web of things? Well, no, it's you basically pull all the stuff into a fairly centralized fabric that does the clever stuff. But if if that data you're pulling in has not been, properly managed, governed, quality from a quality perspective, then the data fabric, like anything else, will just get you a bad answer quicker.
Yeah, and Gartner said something, things like it's an emerging concept, supports data access across the business through data integration. And the point is that it's flexible, reusable, augmented, and sometimes automated. So exploring how data fabric can simplify your data integration, in data integration infrastructure, and reduce your technical debt. That's kind of
I mean, it's interesting when again talking to the guys at InterSystems, and sort of trying to pin them down on where are the really good use cases. Those are where you've got a huge data integration challenge.
Yeah,
lots of different data stores, a lot of data. Needing to pull a lot of those different types of data together to get the answer that you need. So it's not for everybody. Again, it's like anything else, horses for courses. It's not going to take over the world and say everything has to be data fabric or data mesh. But it's certainly for larger companies with big integration issues, lots of different partners, lots of data flowing in from different sources. It's worth looking at.
Yeah, and there was a sort of an extension, maybe not sort of directly related to the fabric, but there's another post that I saw about the modern data stack being out over its skis. So this was.
Does that even mean?
Well, yeah. So it's just saying I think the data stack can't keep up with computing performance and sophistication in the modern data stack, the MDS as they call it, and it's being outpaced basically. So these kind of more traditional analytic workloads need to be modernized, and I don't know, maybe data fabric is kind of the answer to that.
Data fabric could well be one of the mechanisms that brings that to fruition.
Yeah, but they got quotes from Fivetran, Snowflake, Databricks, and even Google on that as well. So maybe we can explore that as a.
Yeah, I mean, interestingly, we didn't have people like Snowflakes and Databricks in the market update that Bloor did on Data Fabric. You know, so I'll share the link to the Data Fabric report.
Yeah, interesting. Okay, yeah, so there's definitely Data Fabric, an interesting topic, not to be confused with data mesh and all the other previous terms. Yeah, so it'll be interesting. Again, let us know if you guys have kind of heard of the term. Are you doing data mesh? Are you looking at Data Fabric? Anything like that? If you talk to anybody around that, please let us know in the comments if you have any ideas around that, or actually kind of what's your strategy at the moment. You know, if you guys are kind of working for an enterprise, what is the approach that you guys take? Is it data mesh? Is it kind of data lake, or any of the sort of previous technologies? Again, drop us some comments, let us know what your views are on this whole thing. Okay, so I think we're there, Paul. Thanks as always for all your inputs. Really interesting topics, and insights were fantastic as always. Info for everything on Paul and all the stuff that we've talked about, and then some, will be in the description of the video. Yeah, so if you guys feel that any of these kind of topics are interesting, let us know. If you want us to maybe focus on specific topics in the future for Class Data Play, again, drop us a comment and suggest some ideas. We're certainly open to to doing that. We tend to kind of compile these as we go along. If things are kind of interest to us, then we'll look at them. But if you have any other ideas and stuff that you've come across, do let us know. We'll certainly consider that for a future episode. That's it for now. Hope you guys have all enjoyed it. Please don't forget to subscribe to the channel, and we will see you next time. Bye for now.
Bye.
Thank you for watching. Please don't forget to subscribe to the channel to support me. You may also want to check out some of the other videos on this channel. Bye for now.